All right, my friends, let's see how it went. First thing I do is fix their notation. Y prime basically means dy dx unless stated otherwise. And then I'll bring everything else down here. I kind of feel like that square root at some point, I'm probably going to need that to be 1/2 power. So I'm just going to change it now. And then I'm going to separate variables. So I'll multiply both sides by dx, and that means that cosine to the 4th x needs to be divided over as well. So I'll have dy equals tangent to the 1/2 x. And then when I divide by cosine to the 4th x, I get basically, what would that be? Secant to the 4th x and then dx. Hopefully that makes sense. Okay. Now from here, so I've got tangent and a combo of tangent and secant. So let's just kind of play with it in our heads. Okay. So if I let u equal tangent, then my du would be secant squared. And so I'd have to save 2 of these secant squareds off to the side for du, and I'd be left with an even number of secant squareds left. So that's the winner right there. I can tell you right now. So let's let u equal tangent of x. Derivative of tangent is secant squared x. Hopefully you're up to date with your formulas, or this has probably been a bit painful for you. Okay, secant to the 4th, I now see that I need to split that up as secant squared times secant squared. Always reserving my du off to the end. So replacing that, this would be u to the 1/2. And then secant squared is equal to 1 plus tangent squared, or 1 plus u squared. I'm going to go ahead and multiply that in. There we go. Okay, actually, I should probably have grouping symbols. All right, and then from there, I'm just going to integrate both sides. I suppose I could have done that earlier as well. So I'd end up with, remember, there's a invisible 1 in there. So the antiderivative of 1 with respect to y would be y, technically plus a constant, but I'm just going to merge the constants on the right side. Power rule on u to the 1/2 would give me 2/3 u to the 3/2. Let's see, add 2/7 u to the 7/5, 7/2, ooh, plus c. There we go. Back substituting, let's see, we'd have 2/3. Let's see, u was tangent of x. Like so. This is one perfectly a good version of the answer. Just getting you ready for multiple choice situations. Another perfectly good version of the answer would be where the common factor has been factored out front. And to get that done easily, you could always think of 3/2, like either in your head or on paper as 1/2, 7/2 as 3/2. Anyway, and you could also replace 2/3 and 2/7 with the fraction over 21. So you'd have common denominator. Let's see, 2/3 would be 14 over 21. And 2/7 would be 6 over 21. And then you could factor out the common factor for the fractions and the tangent part. And so another version of the same answer, let's see, would have 2 over 21 factored out for the fraction part, and then tangent of x, it looks like. No, tangent of x, square root tangent of x is the common factor, huh? Okay, times 7 plus 3 tangent of x. There we go. Okay, so there's a factored form of the answer as well, just in case it's multiple choice and you need to do that. There you go. Oh man, last problem, my friends. Put you back into it. Example 5, the challenge problem of the lesson. Integrate x times sine squared x dx. Good luck.